for today is all about diffraction pattern and polarization. So this morning, I just wanted to share my understanding about my assignment. I hope that you could understand and that there is something going on, and it's just my understanding. So I hope you will understand it. So let's start. So I'm going to begin with diffraction pattern. So in the diffraction pattern, I'm going to focus in the slit diffraction pattern. So this diffraction pattern is the interference pattern that results when there is a wave or a series of waves undergoes diffraction. So when it also defined as the bending of waves around the corners of obstacles or through an operator into the region of numerical shadow of the obstacle. Here was shown as an example of single slit diffraction. So this monochromatic light passing through the single slit has a central maximum and a smaller and dimmer maxima on the other side. So this central maximum is larger than those the other side, and that the density decreases rapidly in either side. So in the contrast, a diffraction grating produces evenly spaced lines that dim slowly on either side of the center. So we consider here that the light is coming from different parts of the same slit. So according to Fujin's principle, every part of the wavefront in the slit emits a wavelengths. So these are like rays, and that start out in the face, in the head, in all direction. So each ray is perpendicular to the wavefront of a wavelength. So let's assume that the screen is very far away to compare with the side of the slit. Rays that heading toward a common destination are nearly parallel. So when they travel straight ahead, so as this figure shown, so when they travel, this second figure is shown that when they travel straight ahead, so as a figure, this figure shown, so they remain in the face and the central maximum is obtained. So however, when the rays travel at an angle relative to the original direction of the beam, so each travels a different distance to a common location, and they can arrive in or out of the face. So let's have an example. That's all for single slit diffraction. So let's move on to polarization. So polarization is a phenomenon in which waves of light or other radiation are restricted in the direction of the vibration. So I'm going to focus about polarization by reflection. So let's proceed. And polarized light can also undergo polarization by reflection of non-metallic surfaces. So the extent to which polarization occurs is dependent upon the angle at which the light approaches the surface and upon the material that the surface is made of. So, when the surface is metallic, it reflects light with a variety of bivisional directions. Such reflected light is unpolarized. So, however, if non-metallic surfaces such as asphalt, roadways, snowfields, and water reflect light such as that there is a large concentration of vibration in a plane parallel to the reflecting surface. So, for example, a person viewing objects by means of light, so reflected off non-metallic surface, will often perceive a glare if the extent of polarization is large. So, fishermen are familiar with this glare since it prevents them from seeing fish that lie below the water. So the light reflected off the lake is partially polarized in direction parallel toward the water surface. So fishermen are an expert of using the glare. So when fishermen know that the use of glare-reducing sunglasses with the proper polarization axis allows for the blocking of this partially polarized light. So by blocking the plain polarized light, so the glare is reduced and the fisherman can more easily to see fish located under the water. Just like goggles, something like that. Yeah. So there is a figure. So, for example, so the sun and many other light sources produces waves so that are randomly polarized. So, as we can see in this figure, so the arrow or the direction of the arrow. So, as you can see that, so such light is said to be unpolarized because it is composed of many waves at all possible direction of polarization. And the slender arrow represents a ray of which polarized light. So the bold arrows represent the direction of polarization of the individual waves composing the ray. Since the light is unpolarized, so the arrow point in all directions. So as I said a while ago, so it said that the light is unpolarized because it is composed of many waves.
In this figure, unpolarized light has equal amounts of vertical and horizontal polarization. So, after an interaction with a surface, the vertical components are preferentially absorbed or refracted, leaving the reflected light more horizontally polarized. So, this is a hint of arrows striking on the sides, bouncing up, whereas arrows striking on the tips go into the surface. So what happens when unpolarized light is reflected from a surface? So the vertical polarized light is preferentially refracted at the surface so that the reflected light is left more horizontally polarized.
Let's have a calculation example.
That's all for today, and I hope you learned something from my vlog. Thank you for watching.